Let's see how we do. A law of cosines. Again, will never need to spit this out. I just want you to see it and be exposed to it. So I'm just curious if you can follow with me. Will you ever have to do this? No. I just want to see if you can follow, because this is where the law of cosines comes from. If I were to ask you to do a Pythagorean theorem on this one, Pythagorean theorem, what would the setup of that be? What squared plus what squared equals what squared?
A squared plus x squared equals c squared.
A squared plus x squared equals, in this case, b squared. Okay. Then what if I wanted you to do the Pythagorean theorem on this green one? Nice. H squared and an a minus x squared equals a c squared? Okay. Could we distribute that? What would that get me? Oh, sir. Oh, sir. What's a minus x times a minus x going to get me?
A squared minus x squared. No, plus x squared.
A squared. What's that going to get me?
2ax.
Minus an ax. Minus another ax. Plus x squared. I'm going to keep that c squared alive. I heard, maybe Bob condensed it. What is minus 1ax minus 1ax? Yeah, minus 2ax. So I've got that minus 2ax plus an x squared. Oh, this looks nasty, right?
Yeah.
But you guys, does anything, oh, yeah. Check this out. What could I put in for this, what did I make a substitution for real fast? Oh, yeah, look at this. What could I replace h squared plus x squared with?
B squared.
Could I make a substitution there?
Yes.
Okay, and you're like, I wouldn't have come up with that on my own. You're not expected to. It's just, can you follow? Okay, what could I replace this? Oh, sorry, I need a little timeout over here. What if I wanted to focus on, let me go back to this picture, beautiful angle C, and I was curious about the cosine of angle C. And again, SOHCAHTOA only works in a right triangle. What would the cosine of angle C be? Good, adjacent over hypotenuse, so ka. So what would x equal, Mr. Polte? What would x equal?
X equal b times cosine c.
I love it. Could I replace this x? Whoa. Could I replace this x with a b cosine of c?
Yeah.
Sure. And Biscuit's like, I wouldn't have done that, but I'm okay with it. Agreed. I wouldn't have either. So I've got an a squared that I just brought from right there. I got a minus a 2a. Instead of my x, I'm going to say b cosine of c. And that equals my c squared. What? Let me just highlight where things came from. This a squared is this a squared. Minus 2ax minus 2a. This is my x. Whew. And then my b squared came from up here. Whoa. You guys, that's the law of cosines.
Yeah.
What? Any leg squared equals. Is this kind of Pythagorean theorem right here? A squared plus b squared equals c squared?
Yeah.
It really is. So that's Pythagorean theorem. We know that. Minus 2 times each of these legs times the cosine of that angle. Boom, there it is. That is the law of cosines. You're never going to have to prove it, but that's a way that they came up with it. Do we really need it in 3 different ways?
No.
No, I just wanted to show it to you. Let me show you this way. Let's see how we would use this. So this is saying, first of all, who are my golfers? Did you know, and I probably didn't know that. You probably did. A slice always goes to the right and a hook always goes to the left. Did you know that?
I did not know that.
Oh, and does it make sense? Okay, you guys, if I want to know what the length between the ball and the cup are, could I have used yesterday's law of sines?
Yeah.
Yesterday's law of sines is sine of an angle over its side, so I'd have my unknown there, equals the sine of an angle over its side, or the sine of an angle over its side. Do you agree the law of sines, we wouldn't have enough info here?
Yeah.
So this is when the law of cosines is helpful. You guys, if we're looking for this side x, let me check this out. I'm just going to leave this up here on purpose right there. If we're looking for this side x, that's going to be my side c. Again, sides are little letters. Capital letters are the angles. If I'm looking for x, I'm going to make that my c. So we're going to say, all right, x squared is... What squared plus what squared? It's just take the other two sides and square them. What are my other two sides of my triangle? 177 squared and 160 squared. Then it's minus 2 times those same sides, y'all. Minus 2 times those same sides, 177 and 160. Law of cosines has to involve the cosine of the angle across from the side that we're looking for. We're looking for this side, so we're going to use angle 4 degrees, right? You guys, we're going to type all that hubbub in my calculator. That's a lot. 177 squared and 160 squared. Minus 2 times those numbers. And then the cosine of 4. Whoa. What'd y'all get? Exactly. Very good, bud. He's saying 426.97 is what he got as equals x squared. And then he might have done that all in one step, which I'm totally fine with. We do need the square root of that value. 20.7 yards. So on this guy, if we are given this info and we need to solve all the different parts, could I use, again, I don't have enough for law of sines yet. That I would have an unknown in every direction, right? So I can't use law of sines. Would you guys rather find side A or angle B or C first? I don't care. Side A? Okay. Side A. So we're going to say A squared is my other two sides squared. 5 squared and 9 squared? Minus, we often want to make that a plus. And you guys, I'll give you the law of sines and the law of cosines. You don't have to have those memorized. I'll give them to you. Minus 2 times what times what? Times the cosine of, what's A's angle? That's it. And maybe you're Bob and you plug it all into one step with the square root first. 5 squared and 9 squared. Minus 2 times 5 times 9. Cosine of 120. So we're going to say my A was 12.3. Then you guys, you know I'm a firm believer. Work smarter, not harder.
Yeah.
Do you like law of sines or cosines better?
Sine.
I like law of sines too. Now that we've got this info, could we go back to our beautiful law of sines?
Yeah.
We could. And I'm good with that. So let's go right here. So we'd say, are you guys sine people on top or side on the top?
Side on top.
Side, 12.3 over the sine of 120 equals what over what? Which one are we finding? Sure. Love it. Thanks, bud. 9 over the sine of B. So that's just helping us with what we did yesterday. I would cross multiply that 12.288, as Mr. Blake pointed out, times, oh, actually I wouldn't do that yet. I would have 12.3 sine of B equals 9 times the sine of 120. Then I'm going to divide by that 12.3 from my calculator. Divided by up arrow, up arrow, up arrow. And I'm getting 0.63. And then inverse sine it. Thank you, Ritzman. $39.4 degrees. Agreed, Ritz. VC, you agree with my 39.4? Yeah. Do we want to go through all that again? If I've got 2 of my 3 angles, how can I figure out that third? Yeah, let's just get it away from 180. So I've got my 180 minus that 39.4 and my 120. Thanks, bud. 20.6. Let's go draw ourselves a picture. Boop, boop, boop. And again, I'm not drawing right triangles because they're probably not right triangles. A is 24. Side A is 24. Side B is 28. Side C is 18. We got to go law of cosines. I have to find an angle. I'm going to write down what the law of cosines is real fast, just so that you don't have to flip it. B cosine of A. Okay. Now, it's up to you guys. Do we want to find angle A, B, or C? It makes no difference. Which one do we want for? Should we do B for biscuit?
Sure.
B for biscuit. We're finding B. So, biscuit. You agree we already have side B. So I might even rewrite this. Boop, boop, boop. I'm rewriting this just in case that might help some people. B squared equals A squared and boop. And cosine of B. All right. We know what B is, right? Biscuit's 28. Biscuit, what is your number?
For basketball?
Yeah.
23.
Oh, bummer. That would have been great if it was 28. What are my other two sides, you guys? 18 and 24. Minus 2 times those same exact sides, 18 and 24. Times the cosine of biscuit baby. Now, here's where people make mistakes. Here's where people make mistakes. People just take all of this and they subtract or divide all of that. Why do I have beef with that?
You have to subtract the 18 and 24, then divide by the
Yeah, you guys, I'm going to show you. I'm going to show you this way longer that you do not need to show these steps once you understand. Like that 28 squared is 784. I'm going to show this out just to help you see that 18 squared is 324. That 24 squared is a 576. And then if I did 2 and an 18 and a 24, that gets me 864 cosine of B. 324, I need to subtract that. I need to subtract 576 to this side, and then this part is being multiplied by the cosine of B, so I'd have to divide it. So I'm going to say minus 324 and minus 576. Could you have done that on your calculator without showing me all these steps? For sure.
I feel like you could have just added 18 squared and 24 squared together.
Totally. I completely agree. I'm showing it in many steps just to show where this is coming from. Minus 324 minus 576. So I'm at negative 116 equals negative 864 cosine of B. Now what do we have to do there? Bless ya. We got to divide. Thank you, Ritz. We're going to divide by that negative 864, which a lot of people forget, y'all. Again, however you use the shortcuts in your calculator, I'm good with it. And I got 0.13 is the cosine of B. Anyone else at that point? 0.13? And how am I finding B? Second cosine, second answer. 82.3?
Yep.
Oh, so law of cosines to find an angle, I think is terrible. But there's no other way to do it. Now, do you have to show this many steps? No. But it is very tedious because we got to break it apart. Now that I have that angle, could I use my law of cosines that I'm more familiar with?
Yes.
You're welcome to. You're welcome to. We could do it anyway. I'm personally going to practice it with law of cosines again, just so that people can get that practice if they need it. If you're like, I'm good, I'm going law of sines, go law of sines. I'm just going to show this another way. If I'm looking for A, I'm going to do 24 squared is 18 squared plus 28 squared minus 2, 18, 28 cosine of A. And then I'm going to, just like Cooper was saying, I'm not going to write it all out. I'm going to just do it in my calculator. 24 squared. I'm going to subtract that 18 squared. I'm going to subtract that 28 squared. And I'm going to get negative 532 equals negative 1008 cosine of A. And maybe you guys are done because you did law of sines. Negative 532 divided by negative 1008. Inverse cosine. 58.1, anyone?
Yeah.
Thanks, Harville.
What'd you get?
I could have been wrong.
I got a 57.
That's a different question.
Never mind. It's not too thin.
Is it a different word?
I'm on homework. So.
Oh, got you. And then I'm just gonna subtract both of those from 180. $39.6. Give me one sec.
No problem.
We're gonna change this problem to A is 11, B is 14, C is 17, and when we do that, we get 84.8, 40.1, and 55.1. So let's do these three problems, 12, 14, and 29, A and B on the front and back. Rounding to the 10th, we'd be at,
Yeah. 2.8.
yep,